Section 1.6, Solving Linear Inequalities. A linear inequality is the same as a linear equation, except that instead of an equal sign, it uses a less than, greater than, less than or equal to, or greater than or equal to. And remember that when you're graphing these symbols, a less than or a greater than is going to be an open circle, and if it's equal to, it's going to be a closed circle when we're graphing these on the number line. Also remember when solving an inequality, when you multiply or divide by a negative number, you must flip the inequality. So don't forget to do that when we're solving them. Next, the solution to a linear inequality are all the numbers that, when substituted in for the variable, make the inequality true. This is the same as an equation, except that with a linear inequality, there's going to be more than one value that becomes your solution. So again, I have all the faith that you know how to graph this. What I am going to do is, again, just give you an example to refresh your memories, and also to model the work and what I want to see on your number line. So x is greater than -3. So the first thing we need to do is label our number line. As far as I'm concerned, you need to have 3 values on your number line for every x value that you're graphing around. First of all, we're graphing around -3, so that goes in the middle. And then the value to the right of that would be -2. The value to the left would be -4. So you only need the 3 values on the number line. Next, it's going to be an open circle because it's strictly greater than. And then which values are greater than -3? Those are going to be all the values to the right. So again, for the second example, 0 is greater than x. First of all, we need to have 0. The number greater is 1, and the number less, or to the left, is -1. Next, although you don't have to do this, sometimes it makes it easier if you rewrite the inequality, putting the x value on the left, simply because convention has that the x is on the left. X is less than, so make sure when you're rewriting this you flip that inequality as well. X is less than or equal to 0. Less than or equal to 0, so we're going to have a closed circle on the 0. All the values less than that would be the values to the left. Now compound inequalities are, as the name implies, more than one inequality. So we can have an AND inequality, as this first one is, or we can have an OR inequality, which actually has the word OR in it. And for the first one, for an AND inequality, it's important that you understand the difference between AND and OR. For an AND inequality, both conditions must be true. In other words, x must be greater than or equal to -2 and be less than 3. In the second one, x is less than -1 or x is greater than 2 means that it doesn't matter which inequality. So x could be -3 because it satisfies this inequality, but it doesn't satisfy this one. So let's go back to this first one. X is between -2 and 3. So again, you can see how I've modeled my number line, how I want to see that. It's going to be greater than or equal to 2 and less than 3. So what values are greater than -2 would be all those to the right. Less than 3 would be all those to the left. However, it's just these values that are between here. In other words, if I were to have a value of 4, although 4 is greater than -2, it's not less than 3. Number 4, x is less than -1, so it's going to be an open circle. The values less than -1 are to the left, or greater than or equal to 2 are the values that are bigger than that. In other words, the only values that don't satisfy this inequality are the values that are between there. 0 is neither greater than +2, nor is it less than -1. Number 5, you have budgeted $66 a month to spend on yoga classes. Your yoga studio charges $22 a month for membership, plus $5.50 per class attended. Write an inequality describing the possible number of classes you can attend each month. So again, I'm stressing that we need to define our variable. So we're writing an inequality for the possible number of classes you can attend. So that's what we don't know. That's what our variable must be. So the number of classes. Then, how much are we going to spend? Well, what we can spend has to be less than or equal to what we have budgeted. This would be the start of a verbal model. We can continue this by saying that what we are going to spend or what we have to spend is the monthly fee plus the class charge. And the class charge, again, is the price per class times the number of classes. So this would be a verbal model. Our monthly fee now is $22 plus it's $5.50 per class times the number of classes, where X is the number of classes. And this has to be less than or equal to my budget of $66. So now go ahead and solve this inequality. So I get that X is less than or equal to 8. In other words, I have to take 8 or fewer classes per month. Solve and graph the inequalities. So you're going to go ahead and now don't forget at this step, X is greater than or equal to positive 4 because I had to divide by a negative 2. Therefore, I had to flip the inequality. And now go ahead and graph this. Now go ahead and try to do number 7. And what I would do is maybe pause the video at this point and do this on your own and see if you can come up with the correct solution and graph. And the solution is X is less than 6, so there will be a closed circle on the 6 and the arrow going to the left. Solving and graphing a compound inequality simply means that we need to solve this inequality on the left first, and then solve this inequality on the right, and then we'll graph them on the same number line. So go ahead and do that. I made an error just there. I had written plus 3, and actually it's minus 3. So we get X is less than negative 3, or X is greater than 1. And now we'll go ahead and graph those on the same number line. Again, a value of X that we would pick to satisfy this inequality doesn't have to satisfy both of the inequalities. It simply has to be either less than negative 3 or greater than or equal to 1. For a compound inequality that's an AND compound inequality, in other words, 3x plus 5 has to be greater than negative 1 and less than 8, you could write this out as separate two inequalities with that conjunction AND, or you can just solve two inequalities at the same time. So in other words, the first thing we have to do in order to get the X by itself would be to subtract 5. So we need to subtract 5 on all three parts, keeping in mind that we actually have two inequalities that we're solving. So then I'll get negative 6 is less than 3x is less than or equal to a positive 3. Still solving this compound inequality, I need to divide both sides, all three sides, by 3. So I get negative 2 is less than x is less than or equal to 1. And now we're going to go ahead and graph this on the same number line. So now if I were to look at these as two separate inequalities, x has to be greater than negative 2, x has to be less than or equal to 1. But again, the only values that would satisfy both of these inequalities are the values that are between here, so we can't extend either of these arrows beyond the point values between these two numbers. And the final problem. In Illinois, the lowest temperature on record is negative 36 degrees Fahrenheit in January of 1999, while the lowest temperature on record is 117. The highest temperature on record is 117 degrees Fahrenheit in July of 1954. Write the range of temperatures as an inequality. So again, we need to define our variable as F is going to be the temperature in Illinois. So if F is my temperature, the lowest temperature is negative 36, the highest temperature is 117. Therefore, any given day, the temperature is going to be somewhere between negative 36 and positive 117 degrees Fahrenheit. Sometimes these word problems are almost so easy that they seem difficult. Don't read more into the problems than there are. If you have any questions or comments, you can post them here below the video, or please come to class with them. Also, don't forget to go back to the website and do the notes check. Thanks.